Assalamu alaikum dear viewers, hope you are doing well. I am Shoaib Dayo again here with another informative video related to the electrical engineering. Today we are going to perform the simulation of the transformer to observe its operation and measure its parameters when it is a step up or step down. Before doing this simulation in the MATLAB software, let's discuss the fundamental concepts regarding the transformer. The transformer is a static piece of electrical equipment which is used to raise or lower the amount of the voltage at the constant power and constant frequency. The transformer has the two main windings. The winding which is connected with the AC voltage source, that is called as the primary winding. The winding which is connected with the load side, that is called as the secondary winding. When the primary winding is energized from the AC voltage source, the alternating flux is set up in the core of the transformer. This flux links the both winding. The E1 is the EMF which is produced in the primary winding of the transformer, and E2 is induced in the secondary winding of the transformer. It is based on the Faraday's law of electromagnetic induction. Whenever a flux is linking with the coil changes, an EMF is induced in the coil. So before wasting the time, let's do the simulation of the transformer on the MATLAB software. So dear viewers, we need to draw this circuit diagram on the MATLAB software, and that we have to observe the operation of the transformer and also measure the parameters on the primary side and the secondary side of the transformer. So as you can see, this is the circuit diagram. This is the AC voltage source, okay, and this is the ammeter which will give us the primary side current, and this voltmeter will give us the primary side voltage reading, and this is the secondary winding of the transformer. As already I have mentioned that the winding which is connected with the source side, that is called as the primary winding, and the winding which is connected the load side, that is called the secondary winding. So now this is the load, okay. Now we have to draw this circuit diagram or implement this circuit diagram on the MATLAB software, and to observe the parameters when the transformer is a step up. When the transformer is step up means its primary voltage is less and the secondary voltage will be greater, and if the transformer is a step down, then the primary voltage E1 is greater and the secondary voltage E2 is less. So let's do the simulation on the MATLAB software. Okay, now this is the MATLAB software. We go to the power lib. This is the power library. Now this is the power library where you can find out the electrical sources, okay. The different electrical sources are available, okay. AC voltage, DC voltage source, elements in which you can find out different things, loads, okay, and three-phase transformers, single-phase transformers, okay. And also in the power electronics you can find out the different power electronic converters, IGBT, MOSFETs, and different things. And in the machines you will find out the synchronous, asynchronous machines, DC machines, okay. And this is the, and in the measurements you can find out the current, voltage, impedance measurement, three-phase voltage and current measurement, power measurement, multimeters, okay. Now we have to implement this circuit diagram on the MATLAB software. So select the simulink model new, okay, blank model, select, okay. Now what we need a single phase AC source, drag this, okay, and then we need in the elements go to the series RLC branch where you can change it into the load, and this is the ground, okay. And also we need the transformer. You can find out the transformer from this elements. This is the linear transformer, okay. You can take, drag it, and in the measurements we need the current measurements for the measurement of the current, and this will give us the voltage measurement. Now connect the circuit according to this circuit diagram. Okay. Now this is a 3-winding transformer. Make it 2 windings. So this will be 2 windings. So this is the primary winding. This can be the secondary winding. How? This AC voltage source will be connected with the primary winding of the transformer. Okay, this is the load. Now connect this ammeter in series with the primary winding. You can see. Okay. Now this ammeter is connected in series with the primary winding. So now this AC voltage source is connected with the primary winding of the transformer. Connect the ground. Okay. Double click on this will branch type. So we are choosing the resistive load. So just this is the pure resistive load which is connected with the transformer secondary winding as a load. So also we need another ammeter. This ammeter will give us the secondary side current. Okay. And now the load is connected with the transformer. Now the voltage, another voltmeter we require. Okay. So now this voltmeter will give us the secondary side voltage, okay, of the transformer, which is connected across the load, okay, and this will give us the primary side voltage of the transformer. Now we need to display the measurements of the current and the voltage in the terms of the magnitude. So we need the display box. So you can find out this display box from this sinks. So another display box we need for this voltmeter, another display box we need for this ammeter, and again another display box we need the voltmeter of this. Now the measurements are to be measured in the root mean square value. So select here, write the root mean square and drag the root mean square block into the Simulink block. So now connect this root mean square block with this, and this will give us the primary side current. Okay. Again we need another root mean square block. So we need another root mean square block. Okay. We need another root mean square block for the E1 primary, for measuring the primary induced EMF of the transformer. Okay. And also we need the RMS block for the, which will give us the value of the E2 of the secondary side of the, you can see. Now this ammeter will give us the primary side current. So this one is the primary current. Okay. This voltmeter will give us the E1 value, which is EMF induced in the primary winding, means voltage is induced on the primary winding side. This will give us the reading of the secondary current, okay, measured by this ammeter, and this will give us the E2 secondary voltage of the transformer. This voltmeter will give us. So now first of all we need to observe these parameters when the transformer is step up. So in the step up condition of the transformer, this E2 should be greater than this E1, or E1 should be less than this E2. Now change the parameters of the transformer. Okay, now our first condition is that step up transformer, make it step up. So 220 volts we are given. Okay, now go to the transformer block. Now the power is this is the apparent power, 2500 VA and 50 Hz frequency. Now make it step up. So winding 1 is 220 volt and winding 2 is 40 volt. We are taking as output. Okay, now go to the each RMS block, select the 50 Hz frequency, here again the 50 Hz frequency, again here the 50 Hz frequency, and again here in this 50 Hz frequency. Now this ammeter give us the primary current of the transformer, and this will give us the primary voltage E1. This will give us the secondary current of the transformer, and this will give us the secondary voltage of the transformer by this voltmeter, which is connected in parallel across the secondary side of the transformer. Now the first requirement is that first condition is that the transformer is a step up, so observe the parameters. So this secondary voltage should be greater than the primary voltage. So now the primary voltage is less and secondary voltage is greater. Now simulate this. Now you can see uh, primary voltage is 155.6 and secondary voltage, as you can see, 307.8 volts. So means 307 volts is the secondary voltage, which is E2 is greater than this E1, the primary voltage. So this is the first condition of the transformer. When it is a step up, the E2 E2, the secondary voltage is greater than the primary voltage. And now, another property of the transformer is that it is non-linear in behavior. So, according to the transformation ratio, when E2 is divided by E1 is equal to N2 divided by N1 is equal to I1 divided by I2. So, here the first primary winding is the LV winding, so primary current is 6.172, and when the secondary winding is HV winding, you can see the voltage is greater on the secondary side in comparison to that of the primary voltage. So you can see the current is less. So when the voltage is greater, the current is less, and when voltage is less, and then current is greater. So this is the non-linear property of the transformer. Now our second task is that observe the parameters when the transformer is a step down. So now make it a step down. So our winding 1 will be 440 volt and our winding 2 will be 220 volt. Okay, now we are given the 440 volts towards to the primary winding. Now simulate this. Okay, verify the result. Now you can see the primary voltage, even when the transformer is a step down transformer, the primary voltage is greater than the secondary voltage, or secondary voltage is greater than the primary voltage. So now here you can see the primary voltage is 311 volts and secondary voltage is 155.3. So you can see the this is the essential condition of the step down transformer, is that when this E2 is less than the E1, as you can see, or E1 here is greater than the E2. So this is a step down transformer. As you can see, when the voltage is less, the current is high. So this is a secondary current, which is the 1.5 ampere, and when the voltage is greater, the current is lower in comparison to that of the secondary current. So this is the step down transformer, and our load is 100 ohm, so which is a resistive load which is connected with the secondary winding of the transformer. So dear viewers, this was the experiment of the transformer operation when the transformer is connected with the load, and observe, we have observed these parameters of the current and the voltages on both primary and the secondary side of the transformer, and our essential task was whether it is a step up or step down. So this is the a step down transformer. So here the primary voltage is greater and secondary voltage is lesser. So again we can make it as a step up transformer. So make it winding number 1, which is the 220 volts, and winding number 2 440 volts, 440 volts, and we are giving the 220 volts on the primary side. So as you can see, this E1, which is the primary voltage, is less, and secondary voltage, which is 155.6, is the E1, and you can see the secondary voltage is 307.8 volt. So this is a step up transformer. So dear viewers, this was the experiment of the transformer operation in which we have observed all these parameters of the when the transformer is a step up and a step down, and also we have measured all the parameters of the transformer on the both primary side current and voltages, and on the secondary side current and voltage. I hope that you have understood today's experiment. So dear viewers, this was the experiment related to the transformer that we have done on the MATLAB software, in which we have observed its operation and measure the parameters of the transformer when it was a step up and a step down. I hope that you have understood today's experiment, and at the last, do subscribe my YouTube channel Shoaib for more informative videos related to the electrical engineering area. Thank you.